Anyways, welcome to this episode on how do we pass our Common Core algebra regions. And in this episode, we're going to be looking at, before we engage into, like solving regions problems, I just want you to have a general idea of what's going on. I have a stuffed nose, but let's see what's going on. Today we're going to be looking into scatterplots, correlations, the type of correlations that we can have, residuals, correlation coefficient, and coefficient of determination. They might sound familiar to you, they might not be familiar to you, it doesn't matter, we're still going to be looking into that. Alright, so let's start with a scatterplot. What is a scatterplot? Well, it's nothing more than a bunch of data placed in a graph. Let's say I plot point here, 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 right? Whatever, right? So, and here, everywhere, right? So that's what a scatterplot is. Then we trace a line that best fit. Now, we will do that with the calculator, because if we do it by hand, trust me, it's tedious. So this will be the line that best fit. Let's say the points are actually going like this. Okay? Notice that the trend is going down to the right. It's negative. Look, if the line that best fit is not going to go this way, the line that best fit is going to be this way. Okay? A straight line. Well, here we say that this is a negative correlation. Now, if your dots are scattered all over the place and you have no idea where to go, then we say that they have a no correlation. Okay? Like, oh, and by the way, correlation doesn't mean that they are related. Okay? The correlation is just that there is a relationship between the two variables, the x and the y. But that doesn't mean that because they have a relationship, oh wow, I sold, let's say this is, as y increases, x increases. Let's say I sold more apples and all of a sudden the stock market went up. What? Yeah, if I was to plot the points, as I sold more apples, the stock market kept on rising. So we're going to have a positive correlation. But that doesn't mean that one causes the other. Alright? So keep that in mind. Alright. So here we have no correlation. So no correlation. Alright, so now you know what a scatterplot is. Residuals. A residual. And let's just keep talking about the linear relationships, right? So I have a point here, a point here, point here, point here, point here, point here, okay? And a point here, point here, point here, point here, point here. So, by the looks of it, let's say this is the line of best fit. Okay? That's the line of best fit. Now, your residual, a residual is whatever is left over. So, let's say this line predicts, okay, it predicted perfectly. Let's say we have a point here, and a point here. It predicted perfectly these 3 points right here. But now, it created an approximation of what the value should be, okay? This is a prediction line. These are the actual values. Let's say we're talking about height versus shoe size. I just want to say, so this is going to be height and this is going to be shoe size. Alright? And this is going to be the line the best fit, okay? Let's see. The line the best fit, let's say it was, it's this one right here. Now, what is the line the best fit? It's a prediction, okay? Sometimes we don't have all the values, but it's a prediction of where, okay, we're talking about height versus shoe size. The taller you are, the bigger your shoe size, okay? But then let's take a look at the shoe size. So this is 2, 4, 6, 8, 10, 12, 14, something like that. In this case, look at this guy. Let's say, I don't know, I really don't want to give any values, but let's take a look at it. Tall, taller, okay, got taller, right, taller. But then look at this guy. This guy is not that tall. This guy is not that tall. Let's say it's 5 feet. Okay? So at 5 feet, he is wearing size, let's say between 12 and 14, size 13, right? So you're 5 feet, but you're wearing 13. But the line that predicts, okay, the prediction line says that you should be taller. You should be a lot taller if you're gonna be wearing 13. Well, in this case, what we're gonna do is we're gonna check the distance. So this is the predicted value. This is what your height should be. But in this case, your height is not that much. And yet, you wear a size 13. So this, my friends, is what we call a residual. A residual. And a residual is the gap between the gap between the actual value and the predicted value. So the residual is nothing more than the actual value, okay, minus the predicted value. Okay, that's what your residual is. The actual value, and usually it will be like this. It will be on the y-axis. Okay, it will be the prediction on, sorry, the actual value on the y minus the predicted value of the y. Your coefficient of correlation, okay, can be anywhere. Okay, coefficient of correlation, and is denoted by the letter R. Can you see this? Yes. R. Now, the coefficient of correlation can be between 0 and 1, or 0 and, I should not use this one, and let me see, like that. Okay. Between 0 and 1 and 0 and -1. Can you see that? Barely. Okay, now you can. Sure. Let me see. Okay. So between 0 and -, what does that mean? All right, that's what we're going to be looking into the next page. Okay. So in which of these scatter plots do you see a positive linear relationship? Like, you could obviously see it on this one, right? So here our R should be close to 1. Here I can still see the relationship, but in here, let's say it's not obvious. So your correlation coefficient, but it's still positive, correct? I don't see no negative, still positive. So I would say something like a 0.44, just to make up a number. Now, let's say, what happens when we have a scatter plot and we have something like this? Do you see any type of correlation? No. So then here R would be close to 0. Okay? It would be close to 0, or maybe 0. Alright, what about being from 0 to -1? Sure. When the scatter plot and the data seems to be negative, when the correlation is negative, you're going to have something close to -1. Of course, given that it's really evident that it's negative. That's what R tells you, okay? That there's a strong relationship, and that the line of best fit is basically that. Okay, now let's talk about the coefficient of determination. What does that mean? Well, the coefficient of determination actually tells you, and is represented by R squared, okay? R squared, coefficient of determination. It actually determines if your line is the model, okay, is the best model. If the model that you're using is the most accurate to represent the data that is in the scatter plots. Okay, so welcome to the big guns. R squared. Also, R can do this as well. Alright, so we've seen in the previous episodes, okay, how to graph parabolas. exponential functions, what was the other one? Linear functions, right? So then here, what kind of regression line? That's what we're going to be looking into. The regression line is the line that best fit. Okay, what kind of model should I use? Okay, in this Common Core, I think we only use linear, quadratic, and exponential. So the shape of the scatter plot should give you an idea of what to use. If not, then you could just use the calculator. I'm going to show you how to use the calculator. For example, here, a straight line might not be the line that best fit this data. Okay? And even if I was to draw a straight line, I will still get r, and I will still get something called r squared, the coefficient of determination. So here, I'm going to just tell you what it is. Here, my best model will be a quadratic function. This looks like a quadratic function. If I was to do like this, okay, it looks like a parabola more than a straight line. So I would use the quadratic model. Here, it will be the linear model. And our R is going to be very strong. If I had used, let's say I had used a straight line here. Let's say I said that this was the line that best fit. My R's are going to be weak. So you have to make sure that you choose the right model. Alright, and then we have here, it looks, if I was to look at it, right? Let's say I'm using I use a linear model. And I determine that this is the line that best fit, because it goes in between. Then I look at the R square. And the R square is around 0.7. Okay, you'll learn about this in the calculator. But then again, I go and I say, wait, could there have been another model? Maybe the exponential model would have been a best fit for this? Well, you let me know. You tell me. The exponential model looks like a better fit? Of course it does. So then all of a sudden you look at your R square and your R square is 0.95. I'm not saying that's what it is, but it determines the best model to use. Okay? Now what is the coefficient of determination? Let's say R square is 95%. What this means is that 95% of the change in Y can be explained by the change in X. 95% of the variability, okay, of the Y's can be explained by the variability in the X. Last one but not least, 95% of the change in Y can be explained by the change in X. That's basically what it is. And it also, of course, determines whether your model is a good one or not. Let's talk about the greatest integer function. The greatest integer function. Thank God it's Friday. TGI Friday. That's messed up, right? Anyway, the greatest integer function, or as people call them, step functions. Okay? So, let's say we have, okay, and it's represented like this. Remember, f of x and y are the same thing. If I want to say this in two different ways, okay. So, the greatest integer function. So, what it is? Well, it's the greatest integer that is less than or equal to x. Okay? So let's create a table of values. Alright. So is the greatest integer that is less than or equal to x? Well, let's see. If x is 0 here, then y will be 0. If x is 0.2, y is 0. What? Well, what is the greatest integer that is less than, okay, less than or equal to x? The greatest integer, the regular number, is this. Let's say x is 0.8 or 0.85. What is the greatest integer? Well, listen to me. We're not rounding here. This is not a rounding exercise. It says the largest integer that is less than. So here, what is the largest integer that is less than 0.85? 0. Wow. When x is 0.999, let's say 0.9999999, y is still 0. How about when x is 1? Well, what is the greatest integer that is less than or equal to this? It's 1. So if x is 1.5, then y is still 1. X is 1.9. Can you see that? Let's see. Wait, all I have to do is put my hand here. Oh yeah, you can see. 1.9, y is still 1. Continue over here. If x is 2, well, what is y? It's 2 because 2 is the largest integer that is less than or equal to x. Okay. And then, when x is 2.9, what is y? You got it, it's still 2. How about 3? 3. 4? 4. How about negative 1? Well, that will be negative 1. What about when I have negative 1.5? What is the largest integer that is less than or equal to negative 1.5? Negative 2 is the largest integer that is less than or equal to this number. Okay, now let's talk about the graph of these little points. Once again, f of x, okay, the greatest integer function, the step function. Okay, so I hope it makes sense. So now let's have our x and y axis, just for the fun of it. Please help me make them straight. Okay, whatever. Alright, so let's plot the points. So when x is 0.5 around here, okay, y is 0. When x is 0.9 right here, y is still 0. When x is, okay, so then I go from here and I'm going to go all the way to 1, and I am going to leave a open circle. Why? Because 1 is not included in the plotting for 0, when y is 0. Now when x is 1, y is 1. When x is 1, y is 1. So right here, we start with this. And it goes all the way to 2, and you leave it open because 2 is not included in the 1 comma something. Get it? And then, when x is 2, right here, and then you go all the way to 3, see? And then when it's 3, and you go all the way to 4. And that's basically your greatest integration and what we call step functions. We're going to look into this when we solve our more regents problems. All right, let's get to work on the regents problems. Okie dokie, so from now on it's only regents problems, practice, practice, practice. So let's go on to this problem 18. It says Robin collected data on the number of hours she She watched television on Sunday through Thursday nights for a period of 3 weeks. So the data is shown in this table. So it says, using appropriate scale, construct a box plot for the 15 values. All right, that's not a problem. So for this one, we're going to be using the calculator. So whether you have a TI-83, TI-84, the process should be the same thing. So I'm gonna use my TI-84 plus CE. Okay. So what am I gonna do? I am going to basically press. All right. So I'm gonna press the stats key. So boom, stats. Then we're gonna press enter and edit, and we're gonna delete. So to delete anything that's there, you could either do it by hand, by one, or you could just go up to the L1 column, the column, L column, whatever, press clear, and go back down, and everything will be erased. It's a good way when you have a lot of data input in there. All right, so what do I have? Okay, 4.5, so that I'm gonna start with that. Okay, let me see now. Okay, that's better. Yeah, better. Okay, 4, enter, 4.5, enter, 4, enter, 3. Okay, hopefully this should fix the whole thing. So now we press stats, we go to calculate, we press one variable statistics, and let's see what I got. Okay, now everything is okay. Yes, now everything looks fine. My God. All right, so now I'm gonna have to write down everything properly. The minimum is 1. Quartile number 2. Quartile number 1. Quartile number 1 is 2. The median of quartile number 2 is 3. Quartile number 3 is 4. And the maximum is 5. This is what exists. So now it says using an appropriate scale. Wow. Okay, so I'll use an appropriate scale. Using an appropriate scale, on the number line below, construct a box plot for the 15 values. So we got 15 values, and we got 1, 2, 3, 4, 5. Basically, it's the easiest thing in the world. So the scale, I'm gonna go by. Let me see how many hash marks do I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm gonna go by 0.5s. So let me see, 0, 1, 2, 3, 4, 5. Yes. So I'm gonna go 0, 1, 2, 3, 4, and 5. Okay. And now my little box and whisker plot. So where's the median? The median is quartile number 2, which is 3. So I'm gonna go at 3, and I'm gonna do this. Then I'm gonna go to quartile number 1, which is 2. You could use a ruler if you want to. I mean, I really don't have to, but if you want to, you could use a ruler so it looks nice. Okay, see, I went to 2. So that's your box right there. Now the minimum is 1, so I'm gonna go to 1. Where is 1? Right here. Okay. Now quartile number 3 is 4, so I'm gonna go to 4. And then the maximum is 5, so I just go to 5, and that's it. And that's your box and whisker plot. Got it? It was easy, right? All right, let's move on to the next problem. Let me see, do I have to explain anything? Nope. All right, good. 3 points. All right, here. This is problem number 20. It says, which statistic cannot be determined from a box plot representing the scores on a math test in Mrs. not Beker, but okay, the reader's algebra class. Oh, okay. So here we go. First of all, in a box and whisker plot, it's all about the medians. Okay? Let's answer this question. Can I determine the lowest score? Yes, the minimum. The median? Yes, quartile number 2. The highest score? Yes, the maximum. The score that occurs the most? No. So I cannot determine the mode. So answer is number 4. All right, so let's go on to the next problem, which is
20, it says, the dot plot shown below represents the number of pets owned by students in a class. So, 0 pets were owned by 2 students, 1 pet was owned by 2 students. Okay, 2 students own 1 pet basically. Okay, there were 5 students that had a pet. 2 pets, sorry, each. There were 5 students who said that they own 3 pets. And I don't mean by 5 own the 3 pets. No, each student owned 3 pets. So here, 4 pets were owned by 3 students, 5 pets by 2 students, and 6 pets were owned by 1 student. That's crazy. All right, so what I do is, it says which statement about the data is not true. The mean is 3, the interquartile range is 2, the mean is 3, the data contains no outliers. All right, I really don't know. What I'm gonna do is, I'm gonna go into the calculator, okay? And I'm going to input the data. So, remember, we're talking about pets owned by students. So, 0 pets were owned by 2 students. 1 pet by 2 students. So, and you have the numbers right here, right? So 0, 1, 2, 3, 4, 5, 6 go on the first column, L1, and then the number of pets go on the L2. See that? 2, 2, 5, 5. Okay. 3, 2, and 1. So what I'm going to do now is I'm going to calculate the statistics. So press stats, go to calculate, press enter. We have an L1 and we have an L2 as a frequency. Where was it? Oh yeah. So to find L2, okay, you press the second key, and then here you have a menu on the blue ones. The second activates all the blue. So you see number 2 right here, it says L2. So that's basically what you press, and that's what you get. Then you press enter again, and it's gonna calculate everything for you. All right, so let's see, what do we need? Well, let's analyze the situation. What does it say? Which statement is not true? The median is 3. Is the median 3? Yes. Okay, the interquartile range is 2. Sorry, I'm sick actually. How do I find the interquartile range? Well, the interquartile range is nothing more than, okay, Q3 minus Q1. Okay, it's called the IQR. Well, Q3 is 4 minus Q1 is 2, which is 2, then that gives you 2. Okay, so the interquartile range is 2. So interquartile range is 2, yes. The mean is 3. Is the mean 3? Well, let's take a look at the mean. We move all the way up to X bar. All right. And we find that the mean is actually 2.75. See that? 2.75. So the mean is not really 3. So then you know what? This is our answer. The data contains no outliers. Okay, let me show you something. It says that the data contains no outlier. What is an outlier? A value that is way outside our, let's say, our range. I think I showed you how to find the outlier, but let's see now. If I was to do the second stat plot, I want a stat plot, I want it on, and I want it to show me a box and whisker plot with outliers to see if there is any. And that's it. Now show me the way. That's your box and whisker plot, and nope, there are no outliers. So we're good. Let's go on to the next question. Okay. Which situation does not describe a causal relationship? Yeah, if I should have asked you to read it. You would have said casual. No, it's causal. Causal, meaning one thing causes the other. Like, for example, the rooster crowing and the sun rising. Is that a causal relationship? Because the rooster crows, the sun rises? No, that's not causal. Oh, okay, I get it, Beker. Of course. You're smart. You're my student. So let's see what it says. The higher the volume on a radio, the louder the sound will be. Duh. Yes, that's causal. The faster a student types a research paper, sorry, the more pages the paper will have. No, this is not causal. The faster a student types the research paper, the faster it will be done. Not the more pages gonna have. What type of relationship exists between the number of pages printed on a printer and the amount of ink used by that printer? Well, let's see. The number of pages printed on a printer, and the amount of ink used by that printer. Okay, it's a positive correlation, but not causal. Okay, first of all, what do we know? That if you're gonna print pages on a printer, the thing is gonna be causal somehow, okay? A positive correlation. The more papers you print, the more ink you will use? Yes. So it's positive. The more, the more. Bye. You see what I gotta go through here? Uh-oh. It's blurry. Everything is blurry. It's not blurry anymore. Alright, let's move on. Okay, Beverly did a study this past spring using the data collected from a cafeteria. She recorded data weekly for ice cream sales and soda sales. Beverly found that the line of best fit and the correlation coefficient as shown in the diagram below. Alright, so this is her scatter plot, which we spoke about it earlier, and cans of soda, ice cream, bar sold. We could see that there's a positive correlation. We could see that the coefficient, okay, of correlation is high, 0.96, close to 1. All right, so why? Well, because this line of best fit, look, it goes through between most of the points. So there's a strong relationship. Now let's take a look at our choices. It says, given this information, which statement can correctly be concluded? Eating more ice cream causes a person to become thirsty. What? No. Or maybe. No, I don't know. Let me ask you something. If you eat more ice cream, does that make you thirsty? Huh?
No.
No, right?
It gives you diabetes.
It gives you diabetes. Okay, yeah, that's true. Okay, drinking more soda causes a person to become hungry. What? If you drink more soda, do you become more hungry?
No.
No, right? Okay. There is a strong correlation between ice cream and soda sales. Yes, definitely yes. I mean, hello, 0.90 something? That's a very strong correlation. Okay, so then 3 only. See, you gotta use your common sense in here. Got it? All right. So now let's move on to the next problem. Okay, let me see if you can see the whole thing. All right. It says, Emma recently purchased a new car. She decided to keep track of how many gallons of gas she used on 5 of her business trips. The results are shown in the table below. All right. It says, write a linear regression. Okay, welcome to the big guns now. This is real regents now. Write a linear regression equation for this data where miles driven is the independent variable. Round all values to the nearest 100. So a linear regression. What is that? Well, this is a linear regression. Okay, this line of best fit is called the least square regression. All right, and the space between, this is the line of best fit. This is the equation that came up from all these points. Okay, this is the line that best determines the relationship of these points. So this is what we call the predicted value, and these points are the actual values because they were here before the line. The space, the difference, the subtraction between the actual and the predicted is called a residual. Just remember that. Anyways, so I just explained to you. In other words, we're finding an equation that can represent this data. So how am I gonna do this? Easy. Take the calculator. Okay? So we're gonna write a linear regression. Just remember that. Okay. So let's zoom in. Let's turn this baby on. Let's press stat, the stat key. Now we're gonna enter. Now go up to L2, clear, go back down. L1, clear, go back down. All right. And now, let's put the data. It says that the X is the miles driven, so this is the Y. All right, so 150, 200, 400, 600, 1000. This time I'm not making mistakes. Okay, and now let's go to L2. So 150 goes with 7, 10, 19, 29, 51. All right, so now we're gonna write a linear regression. A linear regression can have two forms. Let me explain to you. The first form of a linear regression can be y equals to ax plus b. The second form can be y equals to a plus bx. It doesn't matter how you see it. You know that the number that multiplies the x is going to be your slope. And the number by itself is going to be your y-intercept. Got it? Alright then, so let's write our linear regression. I got my values, and I'm going to go to stat. Okay? Stat, I'm going to zoom out. I think you could see this if you're on your laptop, not if you're on your cell phone. But press stat, and now I want to calculate. What is it that I want to calculate? I want to calculate a line, the equation of the line that best fits my data. So, boom. Do I have that on L1? Yes, I do. Did I put anything on L2? Yes, I did. Do I have a frequency list? How much of one and the others? No, I don't. So here we're gonna delete that. Now we're gonna kill two birds, one stone. So I'm gonna go in. Okay, right here. So it says, do you want to store the linear regression? Okay, this only works on the TI-84 or TI-84 plus CE or TI-84 plus C. Yes, I want to. Where? On the, well, there is a way to do it on the TI-83, but it's very tedious. I could show you if you need me to. All right, so now I am going to store my equation, and I press the key that says vars, variables. And where do I want it? On the y variables. What do I want to store? A function. So you press enter. Now you notice that when you press the y equals, you get something like this. Well, this is exactly what it is. Where do you want to store your equation? Let me store it in y1. Okay? And now calculate. And boom. That is the equation of my line. Now, if you are using the calculator and you did not get r squared or r, then my advice to you is the following. Let me zoom out. Let me explain everything to you. Whether you're using a TI-84 or 84 plus or 84 plus CE, the process is the same. You're going to press, okay, the second key, and you're going to go to catalog. Okay, second and 0. Then, by default, if you look at it, okay, it's going to give you the menu of all the things that you could find in the calculator. Well, you want to turn on the diagnostics. You could scroll all the way down, 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 or you could see that the A is activated. That's the alphanumerical, that means the letters. So I'm gonna go to the D. D right here. And now it jumped all the way to the D. And I'm gonna go to the diagnostics. See that? And you want them to be, you want them on. So you press enter, and you press enter again, and it's gonna tell you that the diagnostics are on. Anyways, let us go back to our regression. Okay. So that is my equation of the line. Notice that he gave it to me in the form of ax plus b. So a is the slope. So I'm going to write it down. All right. So that is my equation of the line. Of course, I guess I didn't read exactly what I was asked for. It says, round all values to the nearest hundredth. Oh, that's easy for me now. Round all values to the nearest hundredth. So my equation becomes y equals 0.05x minus 0.92. And that's it. That's it. Let me see. Yep. So this is the equation of your linear regression. Now let me show you what it looks like on the calculator. This is the equation that was put in here by the calculator because we saved it. But let's take a look at the points. So I'm gonna go to the window and I'm gonna adjust it. What do I know about the x-axis? That goes from 150 to 1000. So the minimum is gonna be 0, and the maximum I'm gonna put 1100. Now for the y's, the minimum is 7. Okay, so I'm gonna go to 6, and the maximum is 51. So I'm gonna go to 60. Let me take this thing out. Second stats. Okay. Enter. And now I am going to, it's still on, but I want a scatter plot. See that? Now we're talking. So these were the points that we plotted, and this is the line of best fit. And you can see that it really fits really nice. What else do I want you to see in this problem? Let's take a look at the, let's take a look at the equation one more time. Choice number 4, linear regression. Whoa. Choice number 4, linear regression. Okay, look at this. R is the coefficient of correlation is 0.999. That means that there is a really strong, the force is strong. Strong it is, the force. And R square is also, look, the coefficient of determination says that 99% of the variance or variability on the y axis can be explained, or the data on the y axis can be explained by the data on the x axis.